So in today's lesson, we're going to begin our conversation about current electricity. So you will remember, hopefully, from chapter 11, our conversation about static electricity. And that static electricity tends to build up on materials that are really good insulators. And the reason that that happens is because instead of the electrons being able to move through the object, they sort of stay put, right? So static means staying still. So as a result of that, these electrons can only move really short distances and sort of all over the place. So we would say that the path of the electrons, if we're talking about static electricity, is really unpredictable. And so in terms of its usefulness, it has some definite usefulness and some applications in the real world. But I would argue that current electricity is just as useful, if not more useful, than static electricity, simply because we can control it a little bit more. Let me explain. So as soon as we talk about electrons moving within a conductor as opposed to an insulator like this balloon, if we talk about it moving through a conductor, well, that conductor allows those electrons to flow. And so that can be extremely useful, mainly because we can direct its path. So if we can manage to get all of the electrons to move in the same direction, then we have moving charges, and those moving charges can be very useful in tons of applications because they carry energy with them. So overall, we would say that if we were to compare and contrast static electricity involves electrons not really moving very much at all, just really short distances because they're not able to move through the object that they're stuck on. So usually that object is an insulator. In current electricity, we're looking at the electrons being able to move over longer distances, and the reason that that is the case is because the material that they're existing in is a good conductor, and that allows them to flow through. So the fact that they can be directed is super useful. So from our own experience, we know that current electricity is extremely valuable, and whether or not you're thinking about that, we see its value every time we turn on a light switch or we turn the on switch on our TV, and so on and so forth. But where is that? Where are those electrons coming from that are traveling in that nice controlled path through a conductor? Well, they have to come from some sort of a power source. And so I'm going to talk about just a couple of really common power sources in this note, but we'll expand upon that a little bit later on in the unit. I think the first one that comes to mind for me is a battery. So, you know, like your iPhone or your maybe your iPad and so on and so forth. You know, so batteries are really just portable electrical energy sources, and they generate electrons that allow for your device to be powered. So in this case, I'm showing you a picture of a battery just so we can get an idea about how it's working. So essentially, a battery has two different ends. It has this positive end, that's the end that sort of sticks up, and it has this negative end or terminal down at the bottom in this diagram. And so from the negative terminal, we see that is where electrons are moving outward and will move through a conductor within your device and to whatever is trying to be powered. So in this case, it's a light bulb. And so once those electrons have moved past that object that's going to be using the electrical energy, they move back towards the positive terminal. So just remember that, you know, negative charges are repelled by negative charges, so they're going to want to move away from this negative terminal. But they're also going to be attracted to positive charges. So that's what's going to kind of drive the flow of electrons through this conductive material back towards the positive end. So, but what is generating these electrons here, right? So if you were to look deeply into a battery, you would see that the battery really has different chemicals inside of it, and through those chemical reactions happening between the different materials within the battery, electrons are lost, and that is the source of the electrons in a battery. I have a video a little bit later on that I'm going to post on Google Classroom for you to watch, and that will give you a little bit more insight into how batteries actually work. And so whether or not you noticed or not, it's really important that when you're putting a battery into a device, that you put it in properly according to the positive and negative terminals. So I'm not sure how well you can see this here, but on this little diagram that I'm pointing to, you can see a little plus. And so what that tells me is that the positive terminal needs to go downward here. And you see this little negative here, and that's telling me that the negative terminal has to go towards the top. And that's really important in terms of the wiring, because that will create the correct flow of electrons through your device. So the second source of electrical energy that I want to talk about is our electrical outlet. And so really, if you were to unscrew all of your outlet and just take a look behind what's there, and I don't suggest that you do that on your own, certainly without somebody who's experienced, what you would see is you would see a few different wires connecting to your home's electrical service. So one thing I wanted to notice is this ground wire. So notice that there's a ground screw here, and you screw that into your electrical outlet, and that's just to prevent electrical fires through the buildup of charges, right? So if any extra charges were to build up, they would be grounded, and then there would be far less danger, right? And so that's that third prong that we see on our electrical outlets. I haven't shown it here, but you may notice that in particular in your kitchen or bathroom outlets, there sometimes are a couple of different little switches here in between the two outlets. Actually, let me stop and find a picture of that for you. So what you'll see often in these bathroom outlets are this test and this reset button there, and that's there just to protect you, because if any water comes close to the outlet, like they would potentially in a bathroom or a kitchen, then it will turn off. It will sense that there's a problem with the circuit, and it will turn off. So if you ever are in the bathroom and you have to plug something in and it's not working, make sure to see that whether or not the reset button has been pressed, and because sometimes if there is, it's kind of like a protector, a fuse almost, just to protect you from there being any electrical problems. So what I want you to do, if you're curious especially, I have a video here, a link to a video that I'm going to post on Google Classroom for you, so that you can learn a little bit more about batteries and how batteries were discovered, and how they work. In addition, here are some homework questions that I'd like you to complete, and we can talk about them tomorrow. If you have any questions, please feel free to ask me, and I'll be happy to help.